Hello friend, today I will discuss about what will happen if metering core of a city is connected to protection relay, or why core selection test is important during city primary injection test. So in this diagram you can see that one 33 by 11 kV substation, one 10 MVA transformer is connected in between 33 kV and 11 kV bus. The CT ratio for the LV side of the transformer is 600 by 1, from which a LV over current relay is connected. The pickup for LV over current relay is set as 110% of the full load current, which is in terms of secondary value 0.9625 ampere, or in terms of primary value it is 577.5 ampere, since the full load current is 525 ampere. And TMS is set at zero point 0.1 second as per IEC standard inverse curve. The percentage impedance for the 10 MVA transformer is 8%. From the 11 kV bus, we have two feeder. The CT ratio for these two feeder is 400 by 1. From this CT secondary, overcurrent relay is connected. And overcurrent relay pickup is 1 ampere in terms of secondary value, or 400 ampere in terms of primary value. And TMS is set as 0.05 second. Here, both the curve is IC standard inverse. So in this video, I'll discuss what will happen if by mistake feeder CT metering core is connected to the protective relay. Now the CT parameter for the feeder A and feeder B is same, that is the metering CT. ISF, that is the instrument safety factor, is less than 5. For 15 VA burden and protection CT, it is 5P20 under burden of 15 VA. Again, for transformer LV side, metering CT ISF is less than 5 and 15 VA, and protection CT it is 5P20 and VA rating is 15 VA. Now, since the percentage impedance is known, we can calculate the maximum fault current at 11 kV bus, which is given by full load current in the 11 kV side divided by percentage impedance. So it is 525 divided by 0.08, which is equal to 6562.5 ampere. So maximum through fault current is 6562.5 ampere. In this case, we have neglected the source impedance. Now, as per the setting which is provided in the overcurrent relay, which is connected from the CT secondary side of feeder A. So setting is given as IP, that is the pickup value, as 1 ampere, and TMS equal to 0.05 second. So let us consider fault occur at point F, which is very close to 11 kV bus. So since the fault point is very close to 11 kV bus, this fault current will be equal to the maximum through fault current, that is 6562.5 ampere. So here the PSM becomes 6562.5 divided by 400, since pickup is 1 ampere in terms of secondary value, or 400 ampere in terms of primary value. Here I have calculated PSM as per primary value. Now, as per feeder A, as per IC standard inverse curve, trip time T is given by 0.14 into TMS, value of TMS which is provided in the relay as 0.05 second, divided by PSM to the power 0.02 minus 1. So trip time comes as 122 millisecond. So after 122 millisecond, relay will sense this fault and relay will send a trip signal to the circuit breaker, and circuit breaker will take another 50 to 60 millisecond. So after 180 millisecond, the fault will be clear. Now, due to fault at point A, now what will be the relay trip time for transformer LV over current relay? So for transformer LV over current relay, as per IC standard inverse curve, trip time is 0.14 into TMS. Here TMS is provided in the relay as 0.1 second, divided by PSM to the power 0.02 minus 1. Here PSM is fault current divided by pickup value. Here pickup value is 0.9625 ampere in terms of secondary value, or 577.5 ampere in terms of primary value. So trip time is 281 millisecond. So after 280 millisecond, 81 millisecond, relay will send a trip signal to the breaker. Okay. Now consider that feeder A metering core is connected to the protection relay, that is the overcurrent relay. So the ISF, that is instrument safety factor, for the metering core is less than 5 under rated BA, that is 15 BA. So if 5 times of the rated current flows in the primary side, that is 2000 ampere current flows, then CT will saturate. So fault current is 6562.5 ampere, but since the metering core is connected to the protection relay, it will sense only 5 ampere of the secondary current, or in terms of the primary value, only 2000 ampere current will sense by the relay. So trip time which is given by the relay under this condition is 0.14 into 0.05, which is the TMS of the IEC standard inverse curve, which is provided in the overcurrent relay divided by PSM. Here value of the PSM is 2000 by 400, or 5 to the power 0.02 minus 1. So here the trip time comes as 214 millisecond. Under these circumstances, the trip time for the LV overcurrent relay is 281 millisecond. But relay will sense this fault for feeder A, and it will send a trip signal after 240 millisecond. Again, the breaker will take another 50 to 60 millisecond to clear the fault. So due to close tripping margin in between feeder A and LV overcurrent relay, which is about 66 millisecond, both the feeder A and the transformer will trip simultaneously, leading to the interruption of the power to the feeder B. So that is why the core selection test is very much important during primary injection test of the current transformer.